Good morning, good afternoon, good evening, depending where you're joining us from. We are here for another Wizer CTF reveal. This one today is a relatively easy one. It's one paper. I'll let Itzik introduce the series of the simple ones. There's a reason why we're doing some simple ones as well. And having said that, it's a really important one. I think you can learn a lot about this, and with that said, I'll hand it to Itzik. If you can explain also about the challenge and how to basically hack this code.
Absolutely. Thank you, Gabby. So, yeah, as you mentioned, this is one of the basic series where the goal is to show the vulnerability at a basic level without too many complications, so that you can get introduced with the vulnerability. This is one of them. It's introducing a certain vulnerability that we'll review in a second, in a few minutes, and so it's a simple app that is called Privacy Policy Viewer. Just a URL where you have you provide the company name and you get the privacy policy of that company. Okay, you can see the UI here. If I put Wizer, just goes and brings the privacy policy as a file and shows it here. Very simple, right? So what does it do? There's a simple React Next.js, very similar to React application. It gets the query string here, and it looks for the company name query string argument. Okay. Once it got the company name, it invokes an API named privacy, and we provide the company name, and the API goes and fetches the text of the privacy policy and just embeds it into an element named content within the HTML. That's what it does. Then there's the API endpoint, which is very, very simple. Again, accepting the request, extracting from the request the company name, goes into a certain folder called privacy policies, and then the company name. So very simple. Company privacy policy for company name Wizer will be /Wizer. That's the name of the file, and that's it. Okay. So you probably guessed it. The vulnerability here is what we call directory traversal, or path traversal. Same name for the same name for different name for the same thing. And the way to take advantage or exploit that, if we want to hack anything, is just to go back with .. and get as far as we can. The goal for this challenge, as you can see here, is to read the content of the OSS file past WD. A lot of our challenges does do that because it demonstrates the ability to go into a certain file. So how do we hack that? Let's go and do that straight in the UI. It's probably more explanatory, self-explanatory. If we just provide the company name .. and by the way, I can put as many as I want here, as long as it's more than the two that I actually need to go up enough. I can put 7, no problem. The OS can never go above the root, right? So you can put as many. If you don't know how many times you need to go, you put 7, right? You go all the way up, you get the etc past WD, and here it is. Very, very simple. Instead of the policy, I see this file, which is a serious vulnerability. Okay. So again, to solve it in Wizer, in this case, it's an API endpoint. So you need to provide a JSON, but it's exactly the same. So to solve it here would be just this payload, right? Doing exactly the same. Emulating what the UI will do. We'll send that folder name, company name, and get the past WD file.
Cool. So again, this is a basic one. It's sort of the building blocks, right, of demonstrating the vulnerabilities in a playful manner where you can actually test them out and exploit it. We have another challenge, I think like somewhere
27.
around 27,
Yep.
where it's a little bit more difficult, but again, uses the same technique, but it's like 2 peppers, I think, or something like that.
Yes, exactly. So what we're typically doing that, and again, that's part of the education process, okay, is you get introduced to something very simple to exploit. Then there's another level and set, which basically says the developer thought about it and noticed that there's a vulnerability. They added a layer of validation or sanitization, and so forth, but still they didn't do it good enough. And we're seeing a lot of gaps like that, where developers actually know about a vulnerability. We're talking about this a lot, where the sanitization or the mitigation, the remediation process is not good enough because we don't have deep understanding of the problem. And that's exactly the case here as well.
I remember we spoke yesterday with a customer, and they were telling us that they have pen testers coming in. They're finding a vulnerability. They send the developers the details. The developers fix the symptom. The pen testers come again and just find it again, and just
Exactly.
they just over, they just bypass the fix, and it keeps like that going, like 4 or 5 until they really understand what the problem is. Because many times, and I think you're going to show this in a few minutes, sort of part of the key takeaways is, are you solving this from the root cause, or are you solving it, or are you only solving the symptom? So for
Exactly.
example, if you sanitize this for going back, but you leave some other unsanitized options, then you can bypass that, like special characters, because you didn't think about how you thought about sanitizing only the characters. You didn't know that there's other characters to achieve the same thing.
There are other options. There, your sanitization method and approach might be wrong. And
Yeah.
and I think I think what you're saying is really important, and we should focus on that a lot, because I've seen that live again during real practice building products. We've got the pen testing back with a lot of findings, and then we were iterating through them. And the root cause of the problem is that we didn't find the root cause. We didn't identify the right remediation strategy, which captures the concept of the vulnerability and not just a symptom. You can even end up, having the pen tester tell you, it's good enough because you actually covered all sorts of symptoms, but it's not enough because another pen tester, maybe a little more talented one with a lot more experience, can still find bypasses. So the core issue here is, solve the core cause of those vulnerabilities.
Okay, so let's talk about the root cause.
Yep,
How can we
exactly.
solve it? And
So, as always, there is this write-up here, which walks you through the code, as we typically do, what's wrong with the code, and just, focuses on that piece of code and how do you crack it, which is what we've done without the payload. And then the takeaways. And the takeaways here are pretty important for almost everything you do, right? So the first thing you want to try to do is to totally avoid situations like that. And how would you do that? If you don't embed user input in the path process or in the path string, that won't happen, period, right? So forget about sanitization. There are multiple other ways. So what is a way here, for example? If you provide the company name, I go to the database and bring the folder name, it would never happen because the folder name is something that the developers or the system actually inserts there responsibly, right? And so if you do something like that and translate, and you avoid user input being directly embedded into the path, then you're safe. It doesn't mean that it can't be a store problem, right? Because you can store something wrong and then fetch it. But that is kind of like the way to
that's another CTF that we actually have.
Yes.
Where that's why I think when you architect code, you need to have different team members come together and also discuss security, not just discuss functionality. Like, okay, so this is what we're planning to do. Like, let's think about this for a second, just to make sure that we're at least handling, because I think you said it in one of the other CTFs. You said that you just can't assume that the data that is coming from the database is
exactly
because it's in the database. Because some developers are like, oh, this is from the database. Like it's internal, right? It's from the database. It's clean.
Right.
So
and developers just don't think
too much.
You're right, because developers they're not stupid or not smart enough to understand that, but they're not thinking this way. It's a matter of a mindset. Like, I'm as a developer, oh yeah, it's the database. It's our database. How can it be wrong? Like, there definitely could be wrong, and there are definitely other ways to insert things into the database. So, that's not the point here, but really important. And then the other ways, like, let's say you absolutely require that functionality, because we said let's avoid it. Maybe I can't avoid it. Maybe there is a certain set of circumstances that my functionality calls for it. definitively, and it needs it. So what would you do? There are 2 steps you have to take specifically for directory traversal that will save you. Okay, one is you need to sanitize it clearly, all the special characters and so forth. Only permitted content, for example, alphanumeric characters and so forth. But that's not good enough. In order to be completely safe, what you would do is you'd use an API or library, file system API, to canonicalize the path, to actually pour it into the format, and then you verify that what was canonicalized is actually now starts with the expected base directory. So now you are sure that it's a valid path and it starts with your base directory, and so there's no attempt to go elsewhere out of it.
Yeah. So and it makes me think a little bit, because you can see, if you look at other things, just regular scams like wire fraud and stuff like that, you can see that sometimes the scam starts way early, where somebody's asking to change just the phone number. The scammer is calling, a month before the actual scam, asking to change the phone number, for pretending to be a vendor, asking to change the phone number, which sounds like, oh, this is harmless. This is just a phone number. They didn't have to change the bank info or address, just a phone number, like something small. And then a month later, they call and ask to change the bank info, and guess who they call and verify? The phone number that was last time. So, you can see the creativity is applicable, like to many type of attacks. And this is just interesting. This is something that I just thought about right now. Like, it's the same technique in code. You can save it and you can pull it, and if it's not sanitized. But again, the best way, like you said, is just avoid it altogether. Avoid this attack vector altogether.
Exactly.
That's the best.
Right. So exactly. It's like SQL injection. You want to avoid it altogether. You want to make sure that the string is not built out of user input. How do you do that? There are ways. And there are strategies that are out there, not hard to find. For example, there's this article, which I used as an inspiration for my takeaways here, where you can see here from Portswigger, with the creators of Burp Suite, which we're talking about a lot here. And here you can see a walkthrough and a thought process on how to think about it and what are the best way to do it. So there's no shortage of opportunities to find those things out. You just have to first understand that they exist, and then think about good strategies to avoid them, which is out there, documented libraries and all sorts of other things.
We covered here a while ago an attack where it was cache deception, but I think it also used this technique, if I'm not mistaken, right?
What was it?
It was on the cache. It was cache confusion, and it used something like this as part of the attack. If I'm not mistaken.
Yeah, no, it was a different scenario. It wasn't
no, but it just shows like sometimes you use
absolutely
sometimes for attacking, you're not even getting into a file. You're just using this to confuse a parser or something else to get you to that next vulnerability.
Exactly. So we had an API gateway where kind of like one parser reads the slash as string match, right? Yes. And doesn't find it in a list of require authentication. That's what you're talking about, I think. And then the backend was actually parsing it as, oh, that's okay. It's just a slash. It's part of the URL. And then you kind of like you take advantage, confuse the system to go into something that requires authentication without authentication. And so
this is why it's like so complicated, guys. Like sometimes the attacks are really sophisticated. There are some very creative people out there. So that's why you can't really think about everything. It's just better to avoid this thing, altogether. And in this case, it may just need you to re-architect the way you're doing things. Sometimes it's not just a line of code. It's just like do it differently. And again, that's why collaboration between the different teams that are working together and thinking about security from the get-go and not after the fact and try to solve and patch, things that are already working, and you don't want to slow the development down, or it's in production. Just have those discussions between the team when you're architecting this.
Absolutely, absolutely. The security shift left, I
Yeah.
think, is very important concept to remember, and start early, because then you just do it right from the get-go.
Yeah. And what our customers are doing, they're using our CTFs. They started using our CTFs during the hiring process, where they check if the developers they're hiring have some sense of understanding in security. So this sort of gives them an insight to their thought process when it comes to writing secure code. Anyways, guys, and Itzik, thank you very much. It's always fun learning this type of stuff. It makes you think more creative, and it makes you think like an attacker, which it's you know it's fun to think creative and out of the box, and how to hack a system if you do it for legit reasons. So
Absolutely, absolutely. Yeah, that's what the
cool.
right.
And that's what we want to do. We want to make developers understand the attack mindset, because it will allow them to write better code.
Absolutely. Yep.
Okay, cool. Thank you very much, guys. Bye
Thank
bye.
you, everyone.
See you next time.